Is your Python code running slower than a snail? Did you know that a few simple optimization techniques can make your scripts up to 100 times faster? In this video, we will cover Python performance optimization practice questions and full course review. Master the art of writing high-performance Python code with this comprehensive practice exam. In this video, we dive deep into 30 essential practice questions for Python performance optimization. We cover everything from profiling tools like cProfile to memory management, concurrency, and efficient data structures. Make sure to grab a pen and paper to track your score as we walk through these expert-level questions. Which built-in Python module provides deterministic profiling of programs by describing how often and for how long various parts of the program executed? Option A, time it. Option B, cProfile. Option C, trace. Option D, profile. The correct answer is B. cProfile is the recommended standard library tool for deterministic profiling. Unlike the profile module, which is written in pure Python and adds significant overhead, cProfile is written in C and is suitable for profiling long-running programs. It provides a set of statistics describing execution frequency and duration for every function called. Time it is used for small code snippets, not full application profiling, and trace is used for line execution tracking. Which of the following operations has a time complexity of 1 in a Python dictionary? Option A, iterating through all keys. Option B, deleting an item by key. Option C, searching for a specific value. Option D, sorting the dictionary. The correct answer is B. In Python, dictionaries are implemented as hash tables. Looking up, inserting, or deleting a key value pair has an average case time complexity of 1. Searching for a specific value requires iterating through all entries. N. And iterating through keys or sorting also scales linearly or higher with the size of the dictionary. How can you reduce the memory footprint of a class that will have millions of instances created? Option A, use class inheritance. Option B, use __slots __ to define attributes. Option C, use a dictionary to store attributes. Option D, use the @static method decorator. The correct answer is B. By default, Python uses a dictionary __dict__ to store instance attributes, which consumes significant memory per object. By defining __slots __ equals adder 1 foot, adder 2 feet, Python reserves space for only those specific attributes in a fixed size array instead of a dictionary. This can significantly reduce memory usage when dealing with millions of instances by avoiding the overhead of a per instance __dict__. For a CPU-bound task, which approach is most likely to provide a significant speedup in CPython? Option A, the threading module. Option B, the asyncio module. Option C, the multiprocessing module. Option D, using generators. The correct answer is C. In CPython, the global interpreter lock (GIL) prevents multiple native threads from executing Python bytecodes at once. This means the threading module is not effective for CPU-bound tasks as it cannot utilize multiple cores. Multiprocessing sidesteps the GIL by creating separate memory spaces and interpreter instances. for each process, allowing for true parallel execution on multi-core systems. What is the primary performance advantage of using a generator expression over a list comprehension? Option A. Faster execution speed. Option B. Lower memory consumption. Option C. Easier syntax. Option D. Support for indexing. The correct answer is B. Generators use lazy evaluation, meaning they yield items one at a time and only when requested. This is highly memory efficient because the entire list is never stored in RAM. A list comprehension creates the entire list in memory immediately, which can lead to a memory error or significant slowdown when dealing with large datasets. Which of these libraries allows you to compile Python-like code into C for significant performance gains in mathematical loops? Option A. Pandas. Option B. Requests. Option C. Cython. Option D. Beautiful Soup. The correct answer is C. Cython is a superset of the Python language that additionally supports calling C functions and declaring C types on variables. This allows it to compile Python code into highly efficient C extensions. While NumPy and Pandas use C under the hood, Cython allows the developer to write custom logic that compiles to C speed. What is the time complexity of the listAppend operation in Python? Option A. O(1) amortized. Option B. O(n). Option C. O log n. Option D. O n squared. The correct answer is A. Appending to a Python list is O(1). In the amortized sense, Python lists are dynamic arrays that overallocate space. Most appends just fill an empty slot in the pre-allocated memory. Occasionally, the list must be resized and elements copied, which is O(n). But since this happens infrequently, exponentially spaced, the average cost per operation remains O(1). Which method is the most efficient way to concatenate a large list of strings in Python? Option A. Using the plus operator in a loop. Option B. Using the str join method. Option C. Using str replace single quote. Option D. Using f strings in a loop. The correct answer is B. Strings in Python are immutable. Using the plus operator in a loop creates a new string object at every step, leading to O(n squared). Time complexity. The str join method is optimized to calculate the total length of the final string first and then copy the data in a single pass, resulting in O(n) complexity, which is far more efficient for large numbers of strings. Python primarily uses which mechanism for memory management and object destruction? Option A. Manual memory management. Option B. Reference counting. Option C. Mark and sweep only. Option D. Stop the world tracing. The correct answer is B. CPython's main mechanism for garbage collection is reference counting. Every object keeps track of how many references point to it. When the count hits 0, the memory is immediately freed. However, Python also includes a cyclic garbage collector, using a generation-based approach to detect and clean up reference cycles that reference counting alone cannot handle. Which tool provides a line-by-line report of execution time? helping identify the exact bottleneck within a function? Option A, cProfile. Option B, PyVM monitor. Option C, line_profiler. Option D, memory_profiler. The correct answer is C. While cProfile tells you how long each function takes, it doesn't break down the time spent on specific lines within those functions. The line_profiler library, used with the @profile decorator, gives you a breakdown of time spent on every single line of code, which is invaluable for locating specific bottlenecks in complex logic. To check if an element exists in a large collection, which data structure provides the fastest lookup? Option A, list. Option B, tuple. Option C, set. Option D, dec. The correct answer is C. Sets in Python are implemented as hash tables, checking for existence. Item in collection as O(1) on average for a set. For lists and tuples, Python must perform a linear scan O(n), making them significantly slower as the number of elements increases. Which decorator from the functools module can be used to cache the results of a function based on its arguments? Option A, @functools.cache_results. Option B, @functools.lru_cache. Option C, @functools.memoize. Option D, @functools.optimize. The correct answer is B. The @functools.lru_cache, least recently used cache decorator, wraps a function with a memoizing callable that saves up to maxize most recent calls. This is incredibly useful for speeding up recursive functions like Fibonacci or expensive I/O operations by avoiding redundant computations. Which module is best suited for handling multiple network connections simultaneously without using multiple threads or processes? Option A, asyncio. Option B, multiprocessing. Option C, socket server. Option D, subprocess. The correct answer is A. Asyncio is Python's standard library for asynchronous I/O. It uses an event loop to manage multiple tasks concurrently on a single thread. This is highly efficient for I/O-bound tasks like web scraping or handling many network sockets, where the program would otherwise spend most of its time waiting for responses. When you need to add or remove elements from both ends of a list frequently, which data structure is most efficient? Option A, list. Option B, collections, dec. Option C, array. Option D, set. The correct answer is B. The collections, dec, double-ended queue is optimized for O(1) appends and pops from both the left and right sides, while a standard Python list is O(1) for right side appends pops, removing or inserting at the beginning. Index 0 as O(n), because all other elements must be shifted in memory. What is interning in Python regarding performance? Option A, storing small integers and short strings in a fixed memory location to reuse them. Option B, the process of converting Python code to bytecode. Option C, a method of clearing the cache automatically. Option D, optimizing loop execution using C. The correct answer is A. Python interns certain objects like small integers, typically -5 to 256, and certain strings. This means that multiple variables pointing to the same value will actually point to the same memory address. This saves memory and speeds up comparisons, since Python can check memory addresses instead of values. Which of the following is generally the fastest way to create a list of squares for numbers 0 to 999? Option A for loop with list append. Option B, a while loop. Option C, a list comprehension. Option D, map with a lambda function. The correct answer is C. List comprehensions are generally faster than manual for loops because the iteration happens at C speed inside the Python interpreter, while map can sometimes be faster in specific cases, like when using a built-in function. List comprehensions are widely considered the most efficient and readable way to transform collections in Python. Which decorator provides just-in-time (JIT) compilation for NumPy-heavy Python code? Option A, at numba.jit. Option B, at cython.compile. Option C, at pyjit.optimize. Option D, at numpy.fast. The correct answer is A. Numba is an open-source JIT compiler that translates a subset of Python and NumPy code into fast machine code by simply adding the @JIT decorator to a function. Numba can optimize mathematical loops to run at speeds comparable to C or Fortran without requiring the user to write C code themselves. What is the performance implication of using deeply nested inheritance in Python? Option A, it speeds up attribute lookup. Option B, it increases the time taken for method resolution order (MRO) lookup. Option C, it reduces memory usage. Option D, it has no impact on performance. The correct answer is B. Every time you access an attribute or method, Python must search through the class hierarchy using the C3 linearization algorithm (MRO). The deeper the nesting and the more complex the multiple inheritance, the longer it takes Python to find the requested attribute, potentially slowing down frequently called methods. Which tool can be used to track memory usage over time and identify memory leaks in a Python script? Option A, cProfile. Option B, memory_profiler. Option C, ObjGraph. Option D, both B and C. The correct answer is D. Both memory_profiler and ObjGraph are essential for memory tuning. Memory_profiler provides line-by-line memory consumption, while ObjGraph helps visualize object growth and identify which objects are not being garbage collected due to reference cycles. When working with large datasets, which serialization format is typically faster and more compact than JSON? Option A, XML. Option B, CSV. Option C, Pickle. Option D, YAML. The correct answer is C. Pickle is a binary serialization format specific to Python. Because it is binary rather than text-based, like JSON or XML, it is generally much faster to serialize, deserialize, and results in smaller file sizes. However, it is not secure against malicious data and is not cross-language compatible. What is the first rule of performance optimization according to most experts? Option A. Optimize as you write the code. Option B. Don't do it unless you have a measured bottleneck. Option C. Always use multi-processing. Option D. Rewrite everything in C. The correct answer is B. The famous quote, "Premature optimization is the root of all evil." Donald Knuth highlights that developers often optimize parts of the code that aren't actually bottlenecks. The first step should always be to profile the code to identify where the real performance issues lie before making the code more complex for the sake of speed. Which module provides array objects that are more memory efficient than lists for storing basic data types like integers or floats? Option A, NumPy. Option B, array. Option C, struct. Option D, collections. The correct answer is B. The standard library array module provides a space-efficient way to store C-style data types. Unlike a Python list, which stores pointers to objects, adding 8 to 24 bytes of overhead per element, an array stores the raw bytes, significantly reducing memory consumption for large numeric sequences. Why is accessing a local variable faster than accessing a global variable in Python? Option A. Local variables are stored in a dictionary. Globals are not. Option B. Local variables are optimized to use a fixed array lookup. Load_fast. Option C. Global variables are always encrypted. Option D. There is no speed difference. The correct answer is B. In CPython, local variables are stored in a fixed-size array within the function's stack frame, and looking them up is a simple array index. The load_fast bytecode. Global variables, however, require a dictionary lookup, load_global, which involves hashing the name and searching the global namespace dictionary, making it slower. What is loop unrolling, and does Python do it automatically? Option A. It is an optimization to reduce loop overhead. CPython does not do it automatically. Option B. It is a way to stop a loop early. CPython does it automatically. Option C. It is a way to turn loops into recursion. Option D. It is the process of converting a for loop to a while loop. The correct answer is A. Loop unrolling is a technique where the loop body is repeated to reduce the number of times the loop condition is checked and the counter is incremented. CPython is a simple interpreter and does not perform advanced compiler optimizations like loop unrolling automatically. This is why using vectorized operations in NumPy or tools like Cython is so important for performance. What is the benefit of statistical or sampling profilers like PySpy compared to deterministic profilers? Option A. They are more accurate to the microsecond. Option B. They have much lower overhead and can be used on production systems. Option C. They automatically fix the code for you. Option D. They only work on Windows. The correct answer is B. Deterministic profilers like cProfile intercept every function call, which can slow down the program by 2x 10x. Sampling profilers like PySpy peak at the call stack at regular intervals. This introduces very little overhead, often less than 1 to 5%, making them safe to use for profiling live production applications without crashing them. Which comparison is generally faster in Python? If x is none, or if x equals none. Option A. If x equals none. Option B. If x is none. Option C. They are identical in speed. Option D. It depends on the operating system. The correct answer is B. The is operator checks for identity. Are they the same object in memory? Which is a simple pointer comparison. The == operator calls the __eq__ magic method, which involves function call overhead and more complex logic. Since none is a singleton in Python, is none is both faster and more idiomatic. Since Python 3.7, what performance-related change was made to the internal implementation of dictionaries? Option A. They became unsorted to save space. Option B. They use more memory to improve speed. Option C. They became insertion ordered and more memory efficient. Option D. They were replaced by B trees. The correct answer is C. Starting as an implementation detail in 3.6 and becoming a language standard in 3.7. Python dictionaries use a new compact representation. This change reduced memory usage by 20% to 25% and had the side effect of preserving the insertion order of keys, which simplifies many optimization tasks. What is the overhead of calling a function in Python compared to inlining the code? Option A. Function calls are very expensive due to stack frame creation. Option B. Function calls are free in Python. Option C. Inlining actually slows down Python code. Option D. Function calls only matter if the function is recursive. The correct answer is A. Every time a function is called in Python, the interpreter must create a new stack frame, handle argument parsing, and manage local namespaces. In tight loops, this overhead can become significant. This is why inlining, moving logic inside the loop, or using built-in functions that operate on entire collections at once is often faster. Which of the following is the most efficient way to read a very large file? Multi-GB, without crashing the system? Option A. File, read. Option B. File, read lines. Option C. Iterating over the file object for line in file. Option D. Using a list comprehension on the file. The correct answer is C. Iterating over the file object directly uses a buffer to read the file line by line. This means only a small portion of the file is in memory at any given time. Read and read lines both attempt to load the entire file into memory at once, which will cause a memory error on large files. What is global interpreter lock, GIL, contention? Option A. When multiple threads fight for the lock, causing a performance drop. Option B. When the garbage collector stops the program. Option C. When a dictionary lookup fails. Option D. When the CPU overheats. The correct answer is A. GIL contention occurs in multi-threaded programs when multiple threads try to execute Python code simultaneously. Since only one thread can hold the GIL at a time, other threads must wait. This context switching and waiting can actually make a multi-threaded program run slower than a single-threaded one for CPU-bound tasks. That concludes our 30-question deep dive into Python performance optimization. How many did you get right? If you found this helpful, please give the video a thumbs up and subscribe for more deep dive technical content. For the full-length simulated exam and extra practice materials, check the link in the description below.